Okay, so DMA 30, we're going to look at sections 11, 12, 13, which is applications of percents, percent increase, percent decrease, commission, sales tax, discounts. So we'll be looking at different applications of percents. So let me go ahead and get started with one of these. Okay, so let's say our problem is such that we're told that a family pays $25,900 as a down payment for a home. If this represents 14% of the price of the home, find the price of the home. So they tell us $25,900 is the down payment on a house. And they tell us this is 14% of the price. How much is the house? So if you think of it this way, a percent is going to go over 100. When we're looking at down payment, this would be the amount that's equivalent to the percent. And on the bottom is going to be what would be like the total. So if I'm trying to set this problem up, in the problem here, they tell me the number 14%. So I know the 14 is going to go over 100. They tell me the $25,900 is the down payment on the house, and that this is, meaning this amount is 14%. So the $25,900 I'm going to put in the numerator. What we're going to be solving for is the price of the house. So if you recall, when we look at proportions, if you multiply the two that are diagonal and divide by what's paired with the unknown, that's going to give us the price of the house. So 25,900 times 100 divided by the one that was paired with the blank means the price of the house is $185,000. So here that would be $185,000. So anytime you're doing any of these word problems, they're examples. When they give you examples, they generally have you change the percent to a decimal and either multiply or divide. I like to still use proportions just because it makes everything just flow and be a little bit easier to do. Okay, let me give you another problem. Let's say there are 110 calories in milk. In this case, this will be, in whole milk. We are going to switch to skim milk. And skim milk is going to have 64 calories. I want to know what is the percent of decrease in calorie intake that you have. So we're going to have either an increase or a decrease percent, which is over the 100. Here above on the top right is either going to be an increase or a decrease amount. On the bottom is going to be your starting, the original value, what was from the earlier year. The first thing that we have to do here is we have to calculate. We're going to do 110 minus 64, and that's going to give us the decrease amount. When we calculate this amount, it's going to go in our numerator. Okay, so we're going to do 110 minus 64. So we have a decrease of 46 calories. So the decrease amount is 46. So on the top right, that's the amount of decrease. We're trying to solve for the percent of decrease. The starting value, we started drinking whole milk. So our starting value is the 110 calories. Now that we have our proportions set up, we're going to multiply the two that are diagonal and then divide by the 110. So here we have 46 times 100, and we're going to divide that by 110. That's going to give us 41.88181 repeating. So we get 41.81, and then you would look and it would tell you if you're rounding to the nearest tenths place, the nearest whole number, the nearest hundredths place. So when you're doing a percent increase or percent decrease problem, as I said, you have to come up with the decrease amount. You've got to do that calculation. That's going to go on the top right, and then you divide by whatever the starting value was. Okay. Let's look at sales tax. The sales tax on a $450 TV is $20.25. I want to know what is the tax rate. So again, here the numerator is the tax percent. On the top right is going to be the tax amount, and on the bottom is going to be whatever was the original price. So for this particular problem, we're trying to calculate the tax rate, so we're trying to find the percent. The $20.25 is what the sales tax would be, so that's 20.25 here. The original price of the TV is $450. So as we do this calculation, we're going to multiply these two and divide by 450. So let's do that. So 20 and 25 times 100 divided by the 450. That's going to give us 4.5. So our tax rate here is a 4.5% tax rate. If you were doing a commission problem, same concept. The commission rate, which is the percent 100, the commission amount is in the numerator because it's equivalent to the percent. And then on the bottom would be the total or the original price value of what we're looking at. So in this particular problem, I have a salesperson who earned a commission of $3,520 for selling $32,000 worth of vacuum cleaners. Find the commission rate. So for this, we have 3520 is the earned commission on sales of $32,000 of vacuum cleaners. And we're solving for what percent that would be. What's the commission rate? So we're solving for percent. $3,520 is the commission amount, and $32,000 was the total sales for those vacuums. So again, we're multiplying these two and dividing by the 32,000. So 3520 times 100 divided by 32,000 gives us a commission rate of 11%. So that would be 11%. If we're looking at a discount, if you're doing a discount, we're doing the same process. So let's see. I know a lot of you like to go shopping, so we are going to do a discount. Our discount is going to be 30% off. We are going to purchase several items. Our purchases are going to be $50, $35, and $60. Let's say we're going to get some shorts, some sandals, and a top. Okay? So if we're trying to calculate what is our price after the discount, what is our sale price? First, in this case, we've got to add the 3 items that we're purchasing. Okay, so when we add these together, we got $145 for our total sales. And if it's 30% off, we're going to take 30% of the $145. So what we're trying to calculate here is the discount amount. So the two that we're going to cross multiply are going to be the 145 and the 30, and then we're going to divide by the 100. So 145 times 30 divided by the 100 means we're going to have a discount of $43.50. So $43.50. So $43.50 is exactly the discount amount. If you're asked what is the sale price, and my screen is just pausing, loading again for a second, so bear with me just a moment. So what we're going to do is take the sale price. To calculate the sale price, we're going to take the original minus the discount. So we're going to do 145 minus 43.50, and so 145 minus the $43.50 is going to give us a sale price of $101.50. So $101.50 would be the price for that purchase. Now, we still haven't added in sales tax, but in this particular problem, they're not asking us to do the sales tax necessarily. We're just looking at finding the discount amount. The last thing that we have in section 13, we talk about 2 different types of interest. We have something called simple interest and we have compound interest. For simple interest, we're going to multiply, I'm just going to put SI for simple interest. We get that by multiplying the principal times the rate times the time. So the principal is going to be a dollar amount. The rate, we're going to take the percent and we're going to convert to a decimal. To take a percent and convert to a decimal, you're just going to divide by 100. The time is always going to be listed in years. If they happen to give you, let's say, 6 months, you would put the number of months over 12 and put that fraction in a parenthesis, and then it'll calculate what the decimal amount is for a year. So if we're calculating simple interest, and let's say we have a principal balance of $6,000, and if the $6,000 is 4% interest, 4% we would write as a 0.04, and let's say we're going to calculate it for 3 years. We're going to do 6,000 times 0.04 times 3. And that would be simple interest of $720. The one thing you have to pay attention to in problems is if the amount of money is 6,000 and if the interest is 720, the total amount, if somebody say borrowed it from you and you were needing them to pay you the money back, can they pay you just the 720, just the interest? No. You need them to pay back the principal they borrowed also. So the total, in other words, that somebody would pay back would be the 6,000. Hang on a second. Would be, get it here, would be the 6,000 and the $720. So when you're doing a simple interest problem, true, you just multiply these three values to get the interest. Sometimes the question says, what's the interest? And then sometimes the question specifically wants to know what is the total that's paid back, and you have to be sure you include the original principal amount as well. The last thing that we have is something called compound interest. Compound interest has its own formula, and when you do your test, you will be allowed to write down and use these two formulas on the test. For compound interest, you start with principal, and then we have 1 plus the rate over n, and our exponent is going to be n times t. Now, rate is still going to be the percent written as a decimal. Let me explain the n, the number, and the n. So if you have the word annually written, annually would be 1 time a year. If something is semi or biannually, that would be 2 times a year. If something is quarterly, it would be 4 times a year. And if something is monthly, that would be 12 times a year. So let me give you this amount. So let's say you have $1,000 and that is your principal. Let's say it is compounded quarterly for 5 years at, and let's say it is 7% interest. So if I'm going to solve this problem, I'm going to have a principal of 1,000, 1 plus, my rate is the percent. So 7% is a 0.07. Quarterly means 4 times a year, so I'm going to have 4 in the denominator. My exponent is going to be 4 times 5, or you can actually type 4 times 5 or use the number 20 for your exponent. So let me show you this on the calculator. So on the calculator, we're going to type in our 1,000, do your parenthesis, 1 plus 0.07 divided by 4, close your parenthesis, and then I'm going to raise it to the power, and you technically can type 4 times 5, or you could type the number 20, either way. So that $1,000 is going to grow to $1,414. And when we talk about money, money goes 2 places. So we have a 7, 7. What does the 8 make the 7 do? It's going to round up. So we're going to have 1414 14.78. 1414.78. Always remember, as here we had 778. Think of money goes two places. You look at the third place to determine how to round. So money is two decimal places. Always. Unless they specifically say round to the nearest whole dollar. Okay? So that is the remainder of those sections 11 through 13. And as I said, when you do the test, you'll be allowed to use this formula and also the simple interest formula as well. Okay?